Okay, so today we're going to be talking about the renal medullary concentration gradient. This has to do with your loop of Henle, as you can see here. And that's very important because sometimes if you're dehydrated, then you don't want to excrete as much water. And if you're hydrated, then you want to get rid of maybe some extra bodily fluid. So the loop of Henle, as we descend the descending limb, we're going to be filtering out water. Water is going to be reabsorbed into the blood. And then as we ascend, sodium chloride will be pumped out. And so what that does for us is, as we're descending, if we're getting rid of water, then our osmolarity increases. So here at the very top where we had higher volume of water, we were at 300. As we descend and lose water, now we're at 600 milliosmoles of filtrate. And then as we ascend, if you look, we go from 400 to 300 to 200. And that's because sodium and chloride are leaving the cell, or leaving the tubule, or the descending or the ascending limb of the loop of Henle. So that's very important in establishing, do we want to lose water or do we want to retain water? So in this case, diuresis, we want to get rid of water. And so what we're doing is we're getting water's leaving here, salt's leaving here, but you're not moving a ton of salt over because water's gonna want to increase that. So as you see, water and sodium chloride play a big role in that gradient, and they're a multiplier for that gradient because you don't want to lose too much water and you don't want to be so concentrated that you're dehydrated, right? Or so concentrated that you're overhydrated. So in antidiuresis, you don't want to lose as much water. So not as much water is going through here. You're still losing some, and osmolarity is increasing. But as you go up here, as you'll see in the collecting duct, what do we see? We're losing water, and this increases our osmolarity. So now we have a high concentration with low volume of water. And so this is done by something called ADH. So ADH, what it's going to do with this concentration gradient is the two are going to work together, right? This is pretty regular, normal stuff. We lose water, we reabsorb sodium chloride to get a proper concentration at the end. And in our collecting duct, depending on if we want to go through diuresis or antidiuresis, we insert aquaporins into the collecting duct, and that's all done by ADH. So if we have aquaporins in the membranes here, then water's going to leak out, increasing our concentration. And that is how the renal medullary concentration gradient works. It's a multiplier because, you're losing water, which increases concentration, but you also lose salt, which can decrease concentration. But the final say is ADH and aquaporins and the effect they have on your collecting duct. So that's ADH and the concentration gradient.